Hello and welcome to Applied Database 1. In this session we are going to use Visio to create a database design. As I stated before, you don't have to use Visio, it's just an example. This is the software that I have. You can use any software, whether a software that you can download and install on your machine, or the software that you can use on the net, on the cloud. Just create a drawing for the database design. And the way that we are going to ask for the design is I'm going to show you how to convert the data model into database design, and this is what you need to submit when it's required to create the design. So for Visio, if you have Visio, then you click on Visio Started and then click on the crowsfoot database notation. Once you have that, you can select US units and then save the file in the proper name that's related to your database. Once you start and select the database, you can drag and drop the entity into the middle of the graphing screen and start building your database. And this is the data model that we created last time. So we created the data model from students and courses, and we have, those are the two entities. So we have an entity that's called student, an entity that's called courses, and each one of them will have attributes. We have the list of attributes, and we have the identifier. For the first one is student ID. The identifier for the second one is course ID. So we have the entity, identifier, and the attributes, and then we created an initial relationship between both the many to many, and this is what we talked about last time. Now this is a data model. To create or to convert this into a database design, we need to do the following. First of all, we need to convert all entities into tables. So the entity into table, the identifier into primary key, and the attributes into columns. Data type should be added. So for each column, we need to know what data type that column will be. And then we need to know the data size for that column. Is that column primary key, foreign key, or alternate key? We need to identify those constraints for the different columns. And if they are not one of those, then it will be left without any identification. Then we need to identify if that column is required or not. If it's required, then it's not null, but if it's not required, then we can keep it as null, and this is not the null not null constraints. In addition, relationships will be verified. So let's look at the data model that we created last time. This is the data model that we created last time, and we're going to start converting the entities into tables, the identifier into primary keys, and the attributes into columns. And to do that, we'll just start changing things. So I will make it with different color. And then I will change and this is just to show the difference between entity and the table. We're going to do the same with the course. Then right click on that entity and say show attributes types. So now I have the type for each one of them. Now remember that we are going to identify those as columns. Student ID is a primary key already, so I'm just trying to change this. So now you see that it's been identified as primary key. And then we can change this one. Since we are dealing with Oracle and we will be using Oracle, integer will not be accepted by Oracle. So we are going to change it into number with precision and scale. And of course, since it's student ID, it will be not null. So it's number with precision and scale and not null. I will do the same for the first name. The first name data type will be variable character, and I can choose the size to be 50. And then of course I need the first name for a student, so it will be not null. And then we do the same for the last name. So it's variable character, size 50, and not null. Can move this a little bit up to give you space to work on that. For this one, I can change it into email. Then I can edit, and the email also will be variable character, but it will be of size 150. It's larger than the name, so we'll give it more space. So 150, and it will be not null. I need the email address for the student, and the email is unique, so it can be an alternative key to the database. I'll change the address into variable character with size of 200, and it's not null. The city also variable character or character. For the address, it might include numbers and names. That's why we did that. For the email, the same. Actually, for the first name, last name, and city, we can just make it character instead of variable character. It's good to have variability in the character and more flexibility, but it's fine. Whatever you choose is fine, as long as it's more of textual in nature of a type for that column. So the city can be also 50 and not null. For the state, it can be abbreviation of only 2, so I can make it character only, size of 2, and not null. For the zip code, actually it's number, and again it's with precision but no scale, so we can put it like that and not null. Once I have all that done for the student table, then I will go to the course table and again right click and show attribute types, and then I will change the course ID into number with 5 and 0 or 5 and not null. The course name, I can make it variable character. $150 or 200, not null. And the course name is unique. In the college, the course name is unique for that department. So for that, it can be actually used as alternate key if necessary. So it will be alternate key for that table. And for the course number, we can make it number with 4 digits and not null. So now we're done creating or converting the entities into tables, the attributes into columns, and we identify the primary key. The identifier is now the primary key, and we identified also the alternate keys. Now the other thing is to verify the relationships. To verify the relationships, we need to understand how they are related to each other. We know that one student can take many courses and one course will have many students. So basically the relation is many to many. When we have a many to many, as I stated before in the last lecture, it's very hard to choose which one is the foreign key or where can I put the foreign key. For that, we said that our solution is either to create an intersection table or association table. So we are going to create a third table to assist me in that. So I can take that relation out, and then I can add what I'm going to add an association table, not an intersection table. The association table will have more columns than the intersection. The intersection is just the foreign keys with no additional columns, but actually I plan to add more. So I already created that. I'm just gonna copy it and paste it here. And you will see that this new table, it will have the student ID and course ID as a primary key. It's a composite, so I'm using the what I used from the primary keys from the other tables as composite primary key here, and at the same time there are foreign keys that will connect those tables to each other with through the association. And again, we said that it's association table because we added two more columns, the location and the time for that course, and that's why it is association and not intersection. We can also add the relation. So it will be many courses. The course is optional to be offered, and then we will have the relation from the relation from the student, and also student will be optional for him to register or for her to register for a course. So registration is optional, offering the course is optional, but once the course is offered, then it will have many students, and once student registered, they will have one or many courses. So this will be the new model, so the new design. So this is the database design. So we converted that into database design, and again, for the database design, the entities has been converted into tables, columns has been, or attributes has been converted into columns, identifier into primary key, and we identified the alternative keys and the foreign keys. We had to do association here because the relation was many to many, and the best to create that relation or to establish that relation is by using association table. I will show you the final. This is the final design. We have it here in the PowerPoint, and it shows all the changes that we did for the design. So now this is it's not a data model, this is a database design. Okay, that will be all for this session. If you have any questions, please feel free to use any of the communication channel to ask, or if you have any concerns. That will be all. Have a great day. Thank you.